When you're conducting mesh analysis, should you make sure that the direction of all the currents in the mesh loops are identical? Or can you set them as counterclockwise or clockwise? How do you handle the current that is flowing through the center branch? In this video, I'll answer these questions in detail and explain you the right way of approaching mesh analysis. The discussion that you're going to see in this video was conducted during a live training session with my FE Electrical and Computer students, and it will help you understand mesh analysis and KVL in a lot more detail. So without further ado, let's dive right into it. Let's quickly take a look at mesh analysis, which basically deploys KVL. Now, there are a couple of things I want you to understand when it comes to mesh analysis and KVL. All right, very simple, straightforward. In this question, you are being asked to figure out the voltage across 6K resistor. When we say we are doing circuit analysis on a given circuit, that basically means that we should be able to comment on and figure out every single parameter for the entire circuit, whether that is current through this 2K resistor, whether that is voltage drop across the 4K resistor, whether that is the total current provided by the source, whether that is the power consumption in individual circuit elements. Does it make sense? This is what circuit analysis means. All right. So not a big deal if somebody is asking us to figure out the voltage across the 6K resistor if we know what we are doing. Okay. So here's the thing. Just two steps that you need to remember, understand, and properly apply for mesh analysis, and you'll be set. Number one, the directions that you set, okay, loops that you set must be identical. What does that mean? You cannot have this guy clockwise and this guy anti-clockwise. Is that clear? If you have 3 loops, all 3 loops should be counterclockwise or clockwise. All right, that's the one thing. The second thing I'll have to explain when I write the equation, and it has to do with the center branch, the common branch. Okay, so don't mismatch these directions. They should all be the same. All right, and how to deal with the center branch depends on which loop you are writing, which I'll explain you shortly. So if I'm writing loop number 1, and notice that I'm assuming clockwise directions over here, I1 and I2. So if I'm writing loop number 1, guys, okay, that basically involves this, correct? I1 and this. Now here's the thing. What did I tell you about resistors? KVL is sum of voltage gain is equal to sum of voltage drop, correct? So if I encounter current going through the 2K resistor I1 times 2K, is it going to be a voltage gain or a voltage drop? Resistors always voltage drop. 2K times I1, voltage drop. 4K times I1, voltage drop. Okay. 6K times, if you look at the center branch, this is the tricky one. We are writing the loop equation. This is the second thing I wanted to explain. Loop equation for loop number 1. Correct? Loop equation for loop number 1. What we are going to assume is that I1, loop current 1, is the dominant current. So when I am figuring out the current passing through 6K, okay, notice that I1 is entering from the top, and if I complete this loop for I2, I2 is entering from the bottom. Can you see that? Okay. Since I am in loop 1, I am going to assume that current I1 is the dominant current. Okay. So I'm going to write this as I1 minus I2, and the net direction of current flow will be like this. Okay. So the delta I that is flowing through this is still following the same direction that I1 is, because I am writing it for loop number 1. And then I'm going to multiply it with 6K. Okay. And how do we so that's basically the key. Whichever loop you are in, that will be treated as a dominant loop current. And when we write for loop number 2, I'll show you how that changes. Now, the other thing is a passive sign convention. Notice that I1 enters the positive terminal of the 12 volt battery and it is leaving the negative terminal. So how do we tackle that? Should that be voltage gain or voltage drop? If the current enters the positive terminal of a voltage source and leaves the negative terminal of the voltage source, it is always a voltage drop. Okay? I find students writing 12 volt on the right hand side saying that, okay, 2K resistor, 4K resistor, 6K resistor, drop, drop, drop. But the 12 volt, because it is a voltage source, better be a gain. Because otherwise, why would you have a zero over here? Should not balance out, right? Wrong. All of these voltage changes for loop number 1 are in fact voltage drops. There is no single voltage gain here. Does it make sense? So these are the fine mistakes that students end up making. Now let's focus on loop number 2. When I'm going through loop number 2, I1 is going to come into play, but in the middle branch. So I have I2 times 4K drop. Current times resistor, always a drop. I2 times 6K drop. Current times resistor, always a drop. I encountered the negative terminal of the battery, this current I2, and it's leaving from the positive terminal. When the current leaves the positive terminal of the battery, that's a voltage gain. So I can either write that as minus 12 over here, or I can say that there is a 12 volt gain because when I move this over here, it becomes plus 12 volt, right? For loop number 2, we actually have a 12 volt gain because the current is leaving the positive terminal. See? These are the fine details that you must understand if you want to score good points on circuits. And circuits carries over to electronics and power in FE electrical, even in linear systems, and circuits carries over 100% into P power. Okay. Now let's handle the 6K resistor. When we are living in this loop, loop 2, we are writing it for I2, right? If the current has to take this direction, then I2 must be the dominant current. We're going to write this as I2 minus I1. Can you guys see this? Okay. That is a key point to understand when you're writing KVL for mesh analysis. How many equations we have? 2 equations. How many unknowns we have? 2 unknowns. Can we solve it? Very easy. Very simple. 2 equations, 2 unknown, and we can go about solving it. Now, interestingly, you find that when you go punch it in the calculator, do hand calculations, whatnot, I1 turns out to be negative. Does that mean my answer is incorrect? No, it just means that it is 10 by 13 milliamp, but the actual direction of I1 is this. As simple as that. Okay. We were interested in V0. V0 was simply the voltage drop across 6K resistor. The voltage drop across 6K resistor was I2 times 6K. As simple as that. So we've unlocked this. Right? This is a level of understanding that we need to have in order to be comfortable dealing with what problems involving KVL, KCL, and KVL and KCL, as you know, forms a basis of circuit analysis. Everything else, Thevenin, Norton, superposition, this, that, is source transformation, they're all based on fundamental Ohm's law, KCL, KVL. Okay. I hope you found this helpful. If you have any questions, feel free to type them up in the comment section of this video, and I'll try to respond as soon as possible. Thanks for your time, and good luck with your exam preparation.